All right, density. The question of density is this. How packed is your party? If I have 40 people at a party, is it packed? Depends on what? How big the room is. So it's a comparison of not only how many people you have, but how big is the room you're in. Does that make sense? If I have 40 people in the gym, you're going to tell me that's not very dense. If I have 40 people in here, it's a little more dense. If I put 40 people in a closet, now it smells really bad. The point being is, it's a comparison of how many people you have and how much space you have. It's a comparison. Just like it's a comparison between mass and volume. How much mass do you have, that's like people, versus volume? How big is the object? Does that make sense? So it's a comparison of grams, people, to cubic centimeters, space. If I were to use the tiles in this room, and I'm at a party that's so packed that I can only fit into 4 tiles, if I use people per unit volume, or as me per tile, right now there's 0.25 people per tile, right? 1, me, divided by 4, right? So there's 0.25 people per tile. If it's so packed I can only stand on 2 tiles, and I don't have anywhere else to go, now it's 1 person divided by 2 tiles, so that's 0.5 people per tile. Or if it's super packed, heck, I might have 2 people in each tile. So now it's 2 people divided by 1 tile, right? So my expression would be 2 people per tile. Now I can do that with lots of people, right? If I have 80 people taking up 40 tiles, I just do the same math. 80 divided by 40 is going to be 2 people per tile. Does that make sense? We're just describing how packed your party is. And that's what we're doing in objects. Some objects, there are a ton of atoms per cubic centimeter. And other ones, there's not that many grams or people per cubic centimeter. Does that make sense? So, density is how packed is your party, or we say mass, how many people, per unit of volume. In this case, we're going to say centimeters cubed or milliliters. Does that make sense? How many people are there per cubic centimeter? The formula for that, of course, is density equals mass divided by volume. And so when we do this, we're going to have some grams, and we're going to be dividing grams by centimeters cubed. Does that make sense when I say that? Because mass is measured in grams, and volume is measured in centimeters cubed. So we're always going to express it as something grams per centimeters cubed, or something grams per milliliter. Does that make sense? Because remember, centimeters cubed and milliliter are the same thing, right? So let's take that golf ball that you guys had. If I want to find the density or how packed the golf ball is, who did the mass of the golf ball? Anyone do the golf ball one in here? No one did the mass of the golf ball? You guys did. What was the mass of the golf ball?
15 grams.
50 grams.
15.
No, it's a lot more than that. 50 grams is probably about right. What did you guys do back there?
46 grams.
46. We'll call it 50 just for argument's sake. Good. What was the volume of the golf ball?
42 milliliters.
42 milliliters. So you did the math and you got?
1.1 grams per milliliter.
Great, grams per milliliter, or you can say gram per centimeter cubed. And again, when you look at like the math properties, can you see the grams per milliliter is right there? Can you see it on the problem? Can you see it? Grams per milliliter is already there. Great. So now, when I play Friendswood Village golf course, and I go to number 16, and there's that big pond on the left, and I hit my ball in the pond, it sinks to the bottom. Why? Because the density of water is 1.0 grams per centimeter cubed. So anything more than 1, it sinks. Who did the block of wood? Anyone? You guys did the block of wood. Great, let's find the density of that. Density equals mass divided by volume. I write the formula every single time so I don't mess this up. My mass would be?
We got 146.9.
That's not a measurement.
Oh.
146.9
Centimeter.
No.
Grams.
Grams, great. Divide by?
289 centimeters cubed.
Great.
And we got, that comes down to about 0.5 grams per centimeter cubed.
So look, there's only half as many people in this party as the party ahead of it. Does that make sense? 0.5 grams per centimeter cubed. So when I throw this block of wood into the water, it's going to float or sink? Float, because it's less than 1.0 grams per centimeter cubed, it floats. You down with this so far, right? So this is pretty simple. All you do is you find the mass, you compare it to the volume. The mass, how many people are there? The volume, how big is the room? And that will give you how many people per centimeter cubed, or how many people per milliliter. Make sense? Cool.